Yeah, now we're talking. Okay, good. And then maybe I can fit in 141. Find the equation of the line passing through the point tree and tangent to that graph. Okay. Y minus y1 equals, and y1 here is 3. And the derivative would be the bottom squared, 3 minus 1 squared, and then the bottom times the derivative of the top, which is 0, minus the top times the derivative of the bottom, x minus 3. Okay, so that's 2 squared. So that's y minus 3 is 6 over 4, 3 over 2, minus 3 over 2 times x minus 3. So you'll get as the answer y equals minus 3 over 2x. And then at the back, we have 9 over 4 plus 3, which is 21 over 4. Let's see if we're right. No, I've done a miscalculation. Hang on. 9, did I say 9 over 2 plus 3? 15 over 2. I said 21 over 4. I'm mistyping on my calculator today. It's disgraceful. 15 over 2. Okay. I think I can squeeze in on the bottom here 142. Determine all the points in the graph of that where the tangent line is horizontal and the tangent line has a slope of -1. So we need the derivative 3x squared plus 2x minus 1 to be horizontal means 0. So if we solve that quadratic, we'll get a third and -1. And then if we sub those points in, well, the -1 would be easy to do. So that's -1 plus 1 is gone. And then 1 minus 1, so that's 0. And then the third now, 1 over 3 cubed plus 1 over 9 minus 1 over 3 minus 1. So that's minus 32 over 27. And then we just have to change this to -1 for the second part. So solving that quadratic would give you -2 over 3 and 0. So then the y values, well, 0 is easy. It's just going to be -1. And then we'll need -2 over 3. So let's calculate that. Okay. Answer cubed plus squared. Okay, that's -5 over 27. Well, I have the program here, so I could actually check it. X cubed plus x squared minus x minus -1. Derivative. And then solve that expression. A third and -1. Yep. And then we want to sub in a third. Yep. And then sub in -1. Yep. And then we also want to solve when line 3 is equal to 1, -1. -2/3 and 0. Yeah, and then we'll just sub in -2/3. Yeah, minus 5 over 27. Good. Good. Okay. You know what? Actually, I can check that really ugly 138 since I'm here, because that was a horrible question. 138. X squared plus 4 over x minus 10. And we want the tangent of 14 at 8. 255 over 16. Okay, maybe I do have the 255, but looks like I might be wrong with my numbers here. Okay, we better check it. We better check it. So if I calculate the derivative here, sub in minus 8, and the y, I want to sub in 8. (109 over 2). Yeah, okay. I said that anyways. Okay. So it's y minus 109 over 2 equals 21 x minus 8. That's minus 257. Minus 257 over 16. That's the slope. I said 255 over 6. I said 6. Why did I say 6? I know it's 16. I must have missed the 1. That's disgraceful. Oh, that's a 1 there. I know it's 16. I wrote a 6. And it's 257. 256. So I have a sign mistake here. 16 minus 1 over 16. 255. 257 here, though. What have I done wrong now? Two times 8 minus 4 over 8 squared. 4 over 64 is 1 over 16. Oh, but I put in minus 8, sorry. (255 over 16). So I just lost this. All right, so that should have said 16. So it means I'm multiplying. I should multiply by 8. That's really, 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 really annoying. I'm so angry with that. So angry. Okay. Sorry. It's disgraceful. Multiply by 16. So that's 16y minus 872 equals 255x minus 2040. So we'd get y equals 255 over 16x minus 73. I think that's what we got earlier, was it? Maybe it is actually. All right, now that's right. 137 correct, 138 correct, 139 correct, 140 is correct, 141 is correct, and then 142 is correct. Okay. All right, success. But I know I'm a bit over time because of my stupid mistake, but let's try and get these last two finished. Find a quadratic polynomial such that, okay, so we've got y equals ax squared plus bx plus c. The first derivative is 2ax plus b. And when it's 1, we should get 3. Then the second derivative is 2a. And that means that at 1, we should get minus 6. So 2a equals 6. So that means a equals 3. Sub that in there. That's 6. So b equals minus 3. And finally, we're supposed to get 5 at 1. So we're supposed to get 5 at a plus b plus c. So 5 should equal c. So the quadratic looks like it's going to be 3x squared minus 3x plus 5. Let's check it out. First derivative is 6x minus 3. When x is 1, we do get 3. Second derivative is minus 6. I thought it said 6. Rats. So that's going to be a minus 6. So that makes the a minus 3, which makes the b, okay, so if that's minus 3, that's 2 times minus 3, minus 6. So the b is 9. So they add together to make 6. So that should be minus 1. So minus 3, 9, and minus 1. The derivative would be minus 6x plus 9. And when x is 1, we do get 3. And the second derivative is minus 6. And when x is 1, we do get 5. So yeah, that looks like it's the answer there. Okay. And then lastly, $144. Car's driving along the freeway and has traveled that distance in t seconds. Determine the time in seconds when the velocity of the car is 0. So that is when is the derivative, because the derivative of distance is speed, or the derivative of displacement is velocity. 3t squared minus 12t plus 9. Oh, actually, I should have the answer for 143. That's not right. Is it? Is that what I said? Minus 1? I think that's what I said. Yeah, I think I said minus 1. Okay. Anyways, we want to solve that equal to 0. So solving that quadratic, you get 3 or 1. Okay, so this question here is a little bit weird. Let me show you. T cubed minus 6t squared plus 9t car is driving along a freeway with traffic, has traveled that distance meters in t seconds. So I would suggest that we have to kind of only accept the answer 1, because once the car has stopped, what's going to happen is it's going to start reversing. Um, you see, a car driving along a freeway with traffic has traveled. Even if the car is moving in reverse, its total distance is traveled is still increasing. In other words, it makes no sense if uh, ds dt is negative, because it's the distance traveled. It's not position, it's not displacement, it's distance traveled. And distance is always increasing. You can never undo the distance you've traveled, even by reversing. So like somebody here who travels 1 meter or 10 meters forward and 1 meter backwards has traveled 11 meters. So if you were to plot their distance and their time, it's only ever increasing, and at worst constant if it's at rest. Now, I think I know what's happening here. I don't think they meant to say. I just think it's so weird because it's a cubic. Even if they meant displacement here, are we imagining the car is reversing on the freeway? Um, it's just really weird. It's really weird. So I really feel strongly about this. I would only take the 1 second answer as being meaningful. Uh, the second answer makes no meaning here because it's physically not possible that the car's distance is decreasing. This cubic equation makes no sense after 1 second. And I feel quite strong about that. So I'm not going to hedge here. The acceleration, let's see what that would be. The acceleration is the second derivative. It's the rate of change of velocity or speed if we don't care about the direction. So that would be 6t minus 12, wouldn't it? 6t minus 12. And t is 1, so the acceleration would be minus 6 meters per second squared. Okay. Now, if you really want to know what the second answer would be, well, 18, it would be 18, it'd be positive 6. But again, I really, really, really take issue with that being an answer. Unfortunately, this is an even question, and so there is no answer at the back. So there is no need to complain because we don't know what the author was thinking as the answer should be. A real shame and a real pity. Okay, I've gone way over time. I'm very tired. You could tell I was tired by mixing up a 6 with a 16. So, look, we'll leave it there for today. Thanks for watching, and I'll see you next time.